Hello guys, I'm very excited to share this new project with you which is called as FSDP QDoRA. Before I tell you what exactly this project is, let me give you a bit of a background because that will help you understand and it makes it more exciting. First, what exactly QDoRA is? It's a new fine-tuning technique. And what is fine-tuning? Fine-tuning is to make a large language model specific to a particular domain. Fine-tuning of a model involves retraining that model on a specific task or data set by adjusting its parameters, typically using a smaller task-specific data set to improve performance on that task while leveraging the pre-trained knowledge of the original model. So that is what fine-tuning is. Now, if you look at this diagram, fine-tuning has evolved a lot over the last couple of years. We had this low rank adaptation, then we had this quantized low rank adaptation, and then Llama Pro paper was published, and then you can see it is a plethora of and flurry of innovation there where we had DORA, QLORA, FSTP, Hugging Face, parameter efficient fine tuning, and then just a few days ago last week Meta released Llama 3, and now Answer.ai has released this QDoRA FSTP, which is simply amazing. So this QDoRA is a memory efficient and scalable technique which is helping us out in fine tuning the models as accurately as possible at a very high level. Now, this QDoRA is as memory efficient and scalable as FSDP QLoRA, and critically is also as accurate for continued pre-training as full weight training. Can you believe that? So instead of now doing full weight training, which is expensive, which takes long time, you can simply do QDoRA. So this is likely to be the best way for most people to train language model. This is how important this research is. And I will drop the link to this paper in video's description, and you will see that they have done some experiments on Llama 2 and also have done some completed initial ones on Llama 3, and the results are very promising. So according to the authors and researchers, they expect that this QDoRA with Llama 3 will allow open source developers to create better models for their tasks than anything that exists today, free or paid. Also, if you look at the results from these preliminary sets, you can see that QDoRA has performed really well even without hyperparameter tuning, which is massive. And these results on your screen are the preliminary testing of this QDoRA or contest DORA on Orca Math dataset by fine-tuning Llama 2. And you can see that in this dataset below, where the low memory QDoRA contest DORA implementation produces much better performance than other method while using much less memory than full fine-tuning. How good is that? So what is happening here is that DORA combines much of the parameter efficiency of plain QLoRa with more granular optimization of fine-tuning, and also using their code. And by the way, they have also provided the full code here, the full training code, which you can go through, and I will drop the link in video's description. So let's first go towards this diagram and then I will go in the flow. So first we had this LoRa, which is a low ranked adaptation. So in this work, the researcher hypothesized that most fine-tuning updates operate at low intrinsic rank. In other words, updating all the model's parameter during fine-tuning is not required, and we should be able to fine-tune models by only updating a subset of parameter. And that is what low rank adaptation is, and it does it by freezing the original linear layer weights and instead training a low dimension representation, and then the output of the frozen layer and trainable LoRa layer are combined to produce the fine-tuned output. Similarly, then we had DORA, as you can see. So DORA is which is a weight decomposed low rank adaptation. The researcher investigated the capacity gap between LoRa and full fine-tuning. They proposed splitting the LoRa layers into two components, one for magnitude and one for direction, and fine-tuning both. This decomposition allows DORA to better match the performance of full fine-tuning while adding a marginal number of parameters to train relative to LoRa. Then we had this research about Llama Pro. In this one, the researcher explored an innovative method for enhancing LLM through a technique called block expansion. This technique strategically adds transformers block to improve model specialization without sacrificing existing capabilities. Specifically, it interleaves new transformer decoder layer which are initialized as identity functions to maintain model output while integrating new domain specific information from tailored datasets. How good is that? And then if you so let me quickly show you this is what the Llama block is, comprising an MHSA mechanism followed by the FFN with Swiglu activation. Also in the second column, the identity Llama block after an identity copy achieved by initializing the output linear matrix to 0 in order to preserve the output from the base Llama model. So this is what this Llama block is. And now eventually after this release of Llama 3, we have this QDoRA FSDP. Now, if you look at very high level, the key insight from this preliminary study, very new project by the way. So the key insight is that QDoRA's edge as a top choice among other quantized parameter efficient method is quite evident from the experiments because it matches or exceeds the performance of full fine tuning but requires far less memory. Also, researchers in this one have said that they expect extensive hyperparameter optimization might ultimately push while full fine tuning to yield the best result, but they haven't checked it out yet. Also, while post quantization significantly degrades performance, it's worth mentioning that they have used BNB NF4 for post quantization, which is a weight only quantization method. Using activation aware quantization methods like AWQ or GPTQ should improve results, though these methods cannot be used with quantization aware fine tuning, and maybe they are prone to data biases and shifts. Now, I'm very excited about this, and one thing I have also checked out is that if you try to understand that why QDoRA works even better than full fine tuning, because that is the most important thing for me, and we won't have to do any full fine tuning. We can use this QDoRA. So my understanding is the reason why it works is that minimization of updates to the unrelated irrelevant parameters, which actually results in lower catastrophic forgetting risks. So I think that on the models like Llama 3, Mistral, and few others, this is going to be a huge success. Anyway, so I will drop the link to this in video's description. Read through it, let me know your thoughts, and if you don't agree with my observation and expectation or maybe hope that this is going to replace a full fine tuning, let's have a discussion. But if you like the content, please consider subscribing to the channel, and if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.